Hey, this is Dr. Thomas C. with Science in Seconds, and I'm here with Dr. Kiko Nakamura Messenger. And of course, she's a curator at NASA Johnson. Hey, Kiko, you have a whole team with you and a huge milestone this week. Tell us about the team and the milestone.
Hi, Dr. Z. Here is the Johnson Space Center's Hayabusa 2 curation team members, including the JAXA delegation who actually brought the precious Ryugu sample for us. Its 500 milligram sample is 10% of the entire Ryugu collection they have, and it was protected by 40 kilogram of the protected gear, and then they brought hand carry all the way in this last very twist of the Omicron variant craziness. We are very thankful that they did it, and now it's stored in a pure nitrogen gas. And then our team is the facility engineer and the sample processors, contamination control folks, and the OSIRIS-REx curator, and we are in a very good hand right now.
Well, so first of all, JAXA members, just so excited to be working with JAXA on this. Thanks, congratulations, first of all, for getting that precious sample back. And we couldn't be more excited to be partnering with you. And we promise already, of course, that as soon as our sample is back from Bennu, we'll send a delegation over to you with, a sample from our side. Working together worldwide is what gets the science. But Kiko, you're a scientist actually doing work there. Just tell me, what are the most urgent questions that you think need to be addressed right now with that sample?
So this Ryugu sample is coming from the very water and organic rich asteroid, and extremely fresh, completely free from the terrestrial organic water contamination. So our goal is to study this indigenous space organics and water that will be the key to answer the origin of solar system and the origin of life.
You know what's really funny, Kiko, when I went to grad school, and I have to admit, it kind of makes me feel really old, and that's what I am, but it was in the 90s, late 90s. I listened to a lot of classes with the on meteorites and composition, and what's so amazing is how rich the composition really truly is of these meteoritic samples. Things we didn't know even before the year 2000, especially really complex molecules. Tell us a little bit about that.
We are going to analyze with much better high resolution and a high precision analytical instrument comparing to your 80s and 90s instrument. We have much better sensitivity on the analytical instrument, so that we can nail down to the very minor component. If we can even detect the very tiny molecules that we never ever seen before.
As we're analyzing this, of course, you have a whole team supporting you, and we often say that when it comes to exploration, teams make us successful, not individuals. And just tell us a little bit, what is the Johnson team doing to really take care and of these precious samples, of course, with a huge history for 50 plus years. What is the Johnson team doing here? Tell us a little bit about that.
We are dedicated to protect this sample from terrestrial contaminations. So right now the sample is stored in a pure dry nitrogen gas, and the sample will never ever see the terrestrial air until it was shipped and then opened by the scientists in their facility. And by doing that, we have the expert of the microbial contamination control expert here, and technicians are making sure the room and glove box is always maintained collectively.
Sounded really exciting. Listen, JAXA, our colleagues at Johnson, and all the scientists and individuals who are going to do research on this amazing precious samples. Congratulations. We can't wait to get started. Congratulations to you, Kiko, and best of luck.